While working with the composite functions, we also want to keep in mind some domain issues and trying to figure out what domains are. And this part can be a little tricky the first couple times working through, so I encourage you to kind of look for this in your book or online somewhere else too, just to get some additional information, just to help you straighten this out. So let's go ahead and look at this composite function, f with g of x. And as we remember, that looks f g of x. And if we write that out, we're evaluating the function f, which is 2 all over x minus 1, but rather than x, we're evaluating it at 3 over x. Or I can say it like this, maybe this is a way that helps you understand it. G of x minus 1. And then I can go ahead and put in its place, rather than an x, the entire g of x, what g of x is. And g of x is 2 all over g of x, which is 3x minus 1. So there's my composite function. However, I know you guys are saying, wait, Willie, that's not reduced. Yeah, you're absolutely right. It's not reduced. So let's go ahead and reduce that. And probably the way I'm going to reduce that right now is multiply it by a clever version of 1, x over x. And in so doing, I'll have 2x, x times this term, so it's this whole thing. X times 3 over x gives me a 3 minus an x. So my composite function is 2x all over 3 minus x. Now that we're looking at, now that we have our composite function, let's evaluate its domain and determine where their domain issues lie. So first of all, we look at g of x. And we want to see, is there any domain issues with g of x? And we see that there are. We see that we can never divide by 0, so we must exclude 0 from our domain. 0 cannot be in the domain. Secondly, we look at our composite function. 2 all over g of x minus 1. And again, we can't divide by 0, so we have to make sure, how do we protect this from not being 0? And it looks like I have to make sure that g of x cannot equal 1, because 1 minus 1 equals 0, and my function blows up. So we have to make sure that g of x minus 1 doesn't equal, that g of x doesn't equal 1, and g of x, so that became 3 minus x, that became 3x minus 1, so g of x in this case is 3 over x. How do I make this a 1? Well, if x were a 3. If x were a 3, I can see it right here. If x were a 3, then I have 3 divided by 3, which is a 1. And then 1 minus 1 is a 0. And there's my problem. So how do I make sure it's not a 0? Make sure I don't include an x that equals 3. So therefore, I have to also exclude the value of 3. And now I can look at my domain. My domain are all values. So I can say it's the union of negative infinity to all the way up to 0. And it cannot be 0. Union that with 0 to 3. And union that with 3 to positive infinity. And so there's my domain, are all real values, except for 0 and except for 3, are written in interval notation. All the values from negative infinity to 0, but not including 0. Values from 0 to 3, not including 3. And all values from 3 to infinity, again, not including 3 in that particular case. So just to quickly review, when we're looking at composite functions, we want to find out if there's any domain issues. And the places to look at is, look at g of x. Is there a problem with a particular number or value in g of x that makes a domain issue, makes the problem blow up? In this case, there was. I can't divide by 0, so I had to exclude 0. Secondly, I look at the composite function right here, and again, I have a problem. I can't let my denominator equal 0, so how do I ensure that g of x minus 1, g of x minus 1 also does not equal 0, and I see that it becomes 0 if x becomes a 3 in that particular case.